morning, welcome to all. This is Tanu Gupta from Ajay Kumar Garg Engineering College. Today I'm going to present a very important topic. Today I'm going to explain a very important topic, that is Bayesian network in machine learning technique, which is a code BCS 055. Okay, so today we are going to discuss our topic Bayesian network. So first we understand what is Bayesian network, what is Bayes, and further we explain what is a Bayes theorem. So a Bayesian network is a probabilistic graphical model which represent a set of variables and their conditional dependencies using a directed Acyclic graph. First we understand what is Bayesian network, what the words show to explain the definition of Bayesian network. So Bayesian network is a probabilistic. Probabilistic means it is based on the probability of two variables. It is a graphical model. Yes, it is shows graphs or which represent some number of vertices or edges, which represent a set of variables and their conditional dependencies. Because Bayesian network is a probabilistic graphical model, a graph which consists of a set of number of vertices and edges, or we can say variables and edges, we show their dependencies. And all of the graph are shown using a directed Acyclic graph. Directed Acyclic graph means the variables are shows by the conditional dependency, means this variable is dependent upon this variable is dependent upon this, using a directed graph. Directed graph, there are some edges that show from one vertices to the another vertices, but in the directed Acyclic graph there can be formed a no cycle. So directed Acyclic graph means a graph that has a directed edges, but that graph does not contain a cycle. If in this graph it would be like this, then they formed a cycle. So this is not a directed Acyclic graph. A graph that has no cycle is called a directed Acyclic graph. So I think the definition of Bayesian network is clear to you. Yes, Bayesian network is a probabilistic graphical model which represent a set of variables and their conditional dependencies using a directed Acyclic graph. It is also called a Bayes network, Bayes belief network, decision network, or a Bayesian model. Bayesian networks are probabilistic because these networks are built from a probability distribution, because it based on a probability distribution. So that is why we are saying the Bayesian network is a probabilistic graphical model. And yes, it also uses a probability theory for prediction and anomaly detection, because this model is used for prediction of another variable, or we can say a target variable, and it is also based on the probability. That is why a Bayesian network is a probabilistic graphical model, because it is based on the probability theory. So this is the overall concept of Bayesian network. In real world applications are probabilistic in nature and to represent the relationship between multiple events. If we want to show the relationship between the multiple events, multiple variable, we are use a Bayesian network to show the conditional dependencies or their dependency between the two variables. We are using a Bayesian network to show the dependencies between the variables or the events. Bayesian network can be used for building a model from data and expert opinion. Obviously, Bayesian network is created using data and from the data analysis or expert opinion, and it consists of two parts. So the Bayesian network consists of two parts. First one, directed Acyclic graph and a table of conditional probabilities. So in the Bayesian network, there could be a directed Acyclic graph. The directed Acyclic graph could be given, and the table of conditional dependencies, which show which variable is dependent upon which variable. So a Bayesian network graph is made up of nodes in R. So a graph is obviously the graph is consists of a number of vertices and edges. Like in the Bayesian network graph is made up of nodes and arcs. Each node correspond to a random variable. Each node, or we can say a vertices, represent a random variable which can be any, and a variable can be continuous or discrete, or the variable or a vertices can be a continuous or discrete in nature. Arc or directed arrow represent the causal relationship. Arcs or directed arrow represent the causal relationship and are dependencies between the random variable. If this is are the two variables and the arc, or we can say a directed arrow, this directed arrow represent the relationship, means this variable is depend upon this conditional probabilities or a relationship between these two variables. Okay, if there is no edges between these two variables, so there is no dependencies between the two variables. Okay, so these directed links are arrow connect to a pair or are nodes in the graph. So these edges, or we can say a arrow, which are used to connect the vertices, nodes or events, or we can say a variable in the graph. These links represent the one node directly influenced to the another node. These links represent this node is influenced to the other node. If there is no directed link, that means nodes are independent to each other. If there is no direct link between these two variables, that means this node is independent of this, means this node is not influenced with this node. Okay, now for example, in this diagram there are four variables, nodes, or we can say our vertices in the graph A, B, C, D. This is our directed arrow, or we can say a arc, and this graph is a directed Acyclic graph. How we can say that this is a directed Acyclic graph? Because they are not going to form a cycle. If there is a cycle in this graph, then it can't be a directed Acyclic graph, because there is no cycle in this graph. So yes, it is a directed Acyclic graph and is also satisfy the property of the Bayesian network. So in the diagram, A, B, C, D are the random variable represented by the nodes in the graph A, B, C, D. If we are consisting node B, which are connected to a node A by a directed arrow like this, then node A is called the parent of node B. Obviously, if A is connected to B like this directed arrow, from this we understand that A is a parent node of B. Node C is independent of node A because there is no directed arc or there is no directed edge between the variable A and C. So A and C are independent variable to each other, or we can say A and C are independent to each other. If there is a changes in variable C or event C, there is no influence, or they not influence to the other variable A. So the Bayesian network graph does not contain any cyclic graph. So in the Bayesian network there can't be a cycle, hence it is known as a directed Acyclic graph, or we can say short in a DAG. Okay, so each node in the Bayesian network has condition probability distribution, like probability of xi parent of xi. Xi, it can be a variable, and parent of xi, which determine the effect of the parent on that node. Means probability of B and parent of B, B of A, means the probability of event B that is affect to its parent node A. Probability effect on that parent node means what will be the effect of variable B of the parent node A. Bayesian network is based on the joint probability distribution and conditional probability. So let's first understand the joint probability distribution. If we have the variable x1, x2, x3, so on up to xn, if we have a n number of variables, then the probability of different combination like a combination of x1, x2, x1, x3, x1, x5, x2, x4, x2, xn, and so on. This is known as a joint probability distribution. The combinations of number of n number of variables. Conditional probability. What is the conditional probability? Conditional probability is a probability of an event occurring given that the another event has occurred. Means, and it is denoted by PA of V. Conditional probability. We denote the conditional probability by PA of V, means the probability of an event occurring given that another event is already occur. Means B, A and B are two event, B already occurred, then what is the probability of A when B is already happened? Okay, so if the two event A and B are independent, then probability of the both the events occurring is equal to the product of their individual probability. If A and B are independent, if the event A and B are independent of each other, then the probability of A of B is a product of probability A and a probability B. If A and B are not independent, if there are two event or two variable A and B, if A is not depend upon B or B is not depend upon A, then their conditional probability is the probability of A multiplied a probability of B. If A and B are not independent, means for example B is a parent, A is a parent of B, A of B, and B is already happened, or we can say B is an event that already occurred and A is going to be happen, then the conditional probability is given by P probability of A intersection B divide by individual probability of B. So these are the two cases when two events A and B are independent on each other, then the conditional probability will be like this, and if A and B are not independent, then the probability distribution can be calculated by using the following formula. For example, like this is a directed Acyclic graph or a Bayesian belief network. In this, there are three variables: rain, sprinkler, and grass wet. Sprinkler is depend upon rain, grass wet is depend upon rain, grass wet is depend upon sprinkler and rain. Okay, so these are given a probability because rain and sprinkler, rain is depend upon sprinkler. Okay, so when there is a rain and sprinkler, okay, when there is a rain and spring, there can be, if there are two variables, then it can be a four combination. If there is a rain or there is not a rain, false means there is no rain, true means there is a rain, then what is the probability of sprinkler? True in the case of true, and false because sprinkler is depend upon rain, grass wet is depend upon sprinkler and rain. The probability of rain is independent on other variable because rain is independent variable, so there is a probability of rain or not rain. So this is the hypothetical values, or we can say a hypothetical probability When there is no rain and there is a sprinkler, then this will be a probability. If not, then so on. Another example we would like to explain in this scenario. For example, Harry installed a new burglar alarm at his home to detect a burglary. Burglary, we can say a theft. The alarm reliably respond at detecting a burglary, but also respond for minor earthquake. The alarm that the Harry installed not only detect the theft or detect about the uh, uh, theft cases, but also detect the minor earthquakes if there is a minor changes or minor uh, crumbling in a uh, room, then the alarm will blow. Harry has two neighbors, David and Sophia, who have taken a responsibility to inform Harry at work when they hear the alarm. So Harry has two neighbors, David and Sophia, who taken a responsibility to inform the Harry at work when the alarm will blow at their Harry house. So David always calls Harry when he hear the alarm, but sometimes he got confused with the phone ringing and call at that time too. On the other hand, Sophia like to listen the high music, so sometimes she misses to hear the alarm. Here, we would like to compute the probability of burglary alarm. So yes, that can be a Bayesian belief network. John calls, Mary calls, earthquake and burglary. Alarm will blow in case of burglary and earthquake. Okay. John calls and Mary calls. If the alarm will blow, then John calls and Mary calls. Probability of burglary, because burglary is not dependent upon anything, then earthquake probability this. And alarm probability is depend upon burglary and earthquake. There are two variables alarm depend. So there are four combination. When there is a theft and earthquake, when there is a burglary and earthquake, then 0, 1 and 1, 1. And there is a probability of alarm. This is 0.95 means when there is a burglary and earthquake, then the probability of alarm is 0.95. When there is a burglary but not an earthquake, then the probability of alarm is 0.94 and so on. John call probability, because John calls is depend upon the alarm. When John listen the alarm at the Harry house, then John call to the Harry. So John calls is depend upon the alarm. So probability of John call when there is alarm is this one, or not call is this one. Mary calls. Mary calls is probabilities depend upon the alarm, probability of alarm and the false. So that can be a Bayesian belief network from which we can multiply or articulate the value, or we can say to show the relationship between the variable by using our dependencies. Bayesian probability represent the degree of belief in that event, while classical probability deal with the true or physical probability of an event. Yes, the limitation of, we are also discussing the limitation of Bayesian network typically require initial knowledge of many probability. Yes, as we shown in the example, it requires initial knowledge of many probability. Quality and extent of prior knowledge play an important role. Significant computation cost. Unanticipated probability of an event is not taken care of. Now we are discussing the Bayes theorem. In the probability theory and statistics, Bayes theorem describes the probability of an event based on the prior knowledge of condition that might be related to the event. Means Bayes theorem describe what is a probability of event based on the prior knowledge of condition. Means what has happened in the past or what are going on. It's depend upon the probability of event happen is depend upon the prior knowledge of condition. So Bayes theorem is a mathematical concept that describe between the conditional probability between of the two events. It is shown by PA of B, PB of A, probability of A, probability of B. This is shown as the event B is already happened and the probability of event A has been occurred when the B is already happened. In this, the probability of event B that is going to be happened, but event A is already occurred, and the Bayes theorem will be given by this formula. So yes, PA of B, as we know that in the conditional probability formula, PA of B is equal to PA intersection of B divided by P of B when A and B are not, when A and B are dependent upon each other. Like in the previous slide we discussed, yes, this one. If A and B are not independent, if A and B are not independent, then PA of B by given this equation. Similarly, B of A like this. It follows PA intersection B, this multiply this and so on. Thus, so by using this we can calculate the Bayes theorem. So technical terms and if we are going to explore the technical terms of Bayes theorem, if we can say A is a hypothesis and B is evidence. Matlab, means B is the evidence that already been occurred and B is hypothesis, then or we can say that is the event is already occurring. Hence PA of B denote we need to find the probability of hypothesis given this either the data is given or we have observed some evidence. Likelihood PB of A meaning probability of evidence given that the hypothesis is true. Prior of A, probability of hypothesis before considering the evidence. Marginal P of B, probability of the given data. So this is a technical terms that is used to explain the Bayes theorem that will be given by this. Thank you so much. This is today. This is a Bayes theorem and a Bayes belief network. In another lecture, we are going to explore what is naive Bayes, what is the difference between a naive Bayes and Bayes theorem, and also we are going to explore the numerical example between the Bayes theorem and